Math 3, Unit 4, Section 1. Today we're talking about equivalent rational expressions. So one thing that we want to remember is that with expressions, we are just simplifying. We're not actually solving for a variable. Equations, where we have equal signs, are where we're solving and finding an answer to a variable. So in this case, all we're doing is going to be reducing these fractions. Now, the first thing that I want us to remember is the difference between a monomial and a binomial. So a monomial, does anyone know how many terms that has? So hopefully you said one term, and a binomial has two terms, and then polynomials have three terms or more. So one thing that you need to remember with regards to this is that when you're dealing with monomials, these right here are both single terms. A binomial is when you have two terms, and so adding and subtracting separates the terms. So even though there's numbers and letters here, this is one term. Everything's being multiplied together, so it is considered one term, where this has a plus, or if you had a minus separating them, that is considered two terms. So monomials can have like things, and we can reduce them. So for instance here, 28 and 7, what do they have in common? Well, they have a 7 in common, so we reduce by 7. So 7 divided by 7, that makes that a 1, and 28 divided by 7 makes that a 4. Okay, also they have a's in common. And so just to kind of write this out, this really, a to the second power is a times a, where a to the fifth is a times a times a times a. And since they are like in terms of them both being a's, we can cancel out 1 for 1, and we are left with, oops, I forgot my fifth one there. We are left with 3 a's. So this answer right now here at the top, okay, is that I'm left with just a 4, because I wrote these out here. And then on the bottom, I have 1 and then 3 a's, which makes a to the third. So you could write that as 1 a to the third or just a to the third. So all we're doing is reducing anything that we can for that fraction. Now, when you come over here to this fraction, when you have a binomial, you can only reduce it if the entire term is the same. So, and then also you can't reduce a binomial with a monomial. So if something's connected with a plus or a minus, it cannot be reduced unless there's another thing that's exactly the same with a plus and a minus. So when you get to problems like this, you want to check to see, well, are there any like terms or anything that I could factor out that would end up making it so that I could reduce it? And so if you look at the top, do you notice something that they have in common? So hopefully you notice that they have a C. So I can factor out a C, my GCF, and when I factor out that C, I'm left with an A plus B. And then this is still over AC. When you look at this now, on the top here, I actually have a monomial term. I have a single term here, and then I also have a binomial that's connected because we have the A plus B. So in this case, this monomial can be reduced with the bottom. See how they both have C's? So we can reduce them because nothing's being added or subtracted with them. So we can cancel out these C's. And right now I'm left with A plus B over A. If you want to keep parentheses around the A plus B, you can. But a lot of people want to reduce these A's. And the thing is, you can't, because this A is actually connected with the B. And I oftentimes think the best way for me to show you why this will not work is like plugging in a value for A and B. So let's pretend that A is 3 and B is 5. So if I were to plug these values into this equation, I would have 3 plus 5 over 3, and 3 plus 5 is 8 over 3. Can we reduce 8 over 3? And the answer is no. 3 cannot go into 8. And if you were to reduce it here, because see how these both have 3's, if I were to cancel that out, I would think that my answer is supposed to be 5. Is 5 and 8 over 3 the same thing? No. Okay, 8 over 3, that's, gosh, what is that? 3 goes into 8 2 times. That's 2 and 2/3. 2 and 2/3 is way different than 5. So you just need to remember that if something's connected with a plus or a minus, the only way you can reduce it is if you have the same thing on the other side of the fraction. Okay, let's go ahead and move on and try this next example. So right now, again, looking at this, could I reduce this 2 and the 6? Hopefully you answered no. And the reason is because right now this is all connected together because it has a minus in between. Okay, up here, once I factored it out, see how the C is being multiplied to this parenthesis, but these are now separate. Okay, and so right now, this whole thing here is connected together. Is there a GCF I can factor out of 2n minus 3? No. So we have 2n minus 3. And then in the denominator, is there a GCF that I could factor out? Okay, so I can factor out a 3. And so when I do that, I am left with 2n minus 3. So now, and again, maybe we want to keep these in parentheses so we can see that those are all together as a binomial. These are the same. See how both of them are 2n minus 3s. And so since they're both the same, we can reduce and cancel out those two binomials. Now, if there isn't anything left on the top, what is actually there? Good, a 1. And so this is going to be 1 over 3. And that's my answer. Okay, moving on to the next one. Again, this is connected with the plus sign. And so these are all kind of stuck together right now. So the only way I can reduce this if I had the exact same thing with the plus in the bottom. And right now I don't. And so in order to check to see if we can reduce, we want to look to see, is there a GCF that I could factor out? Is there any way of factoring this to see if I can end up simplifying it? So on the top, what could I take out as my GCF? All right, hopefully you said 3w to the second power. So when I take out 3w to the second power, I'm left with a 2w plus 5. Okay, and then this is over 24w to the fourth power. Okay, and so looking at this now, I have a binomial, but I also have monomials right here that I could reduce. And so 3 and 24, 3 divided by 3 cancels out, and 3 goes into 24 and becomes 8. And then w squared and w to the fourth, we know that we can cancel out 2 of the w's here, and then 2 of them would cancel out here, which would leave me with 2 left over. And so on the top, I still have 2w plus 5, and in my denominator, I'm left with an 8 and a w squared. So now I have a binomial on the top and a monomial on the bottom, and so I cannot reduce these. I can't reduce any more w's because that whole piece right there is connected together. So that's my final answer. Okay, so we're going to continue using our factoring skills. I can see that there's a GCF here, and on the one below here, it's 3 terms. And so I know I'm going to have to use my trinomial factoring where we do our multiplication and adding. Now, one thing that I don't like the way this is written right now, and so I would rewrite that so it's in descending order. And so we would have negative x squared minus 4x plus 12. The other thing when I'm factoring is that my x squared term needs to be positive. So in order to make that positive, I would need to do what? Hopefully you said factor out by a -1. And so when I do that, I get x squared plus 4x minus 12. At this point now, we're going to check for our multiplying and adding number. And so my multiplying number, so this is a GCF, so we're not thinking about that number there anymore. And so we're just multiplying 1 and -12, which is -12. And my adding number is 4. So what numbers multiply to be -12 and add to be 4? Okay, and so 6 and 2 are the numbers that work, specifically 6 and -2. And again, those multiply to be -12, add to be 4. So when we're factoring, I'm going to go ahead and use the shortcut here, and I'm looking back here. And so my parentheses, I'm going to end up, my x squared is going to split up, and I'll have an x in the front of these parentheses. And then I have 1 plus 6 and a -2. On the top, this is just 2 terms. It's not 3 terms, so it's not trinomial factoring, and we should just check for a GCF. In this case, we have an x. That's our GCF, so we'll take out the x, and we're left with x plus 6. So looking here, do we see any like terms that we can cancel? Good, so the x plus 6's cancel, and on the top I'm left with x and an x minus 2 in the denominator. And my question is, can I reduce this x and this x? Hopefully you said no, again, because x minus 2 is connected. Okay, and so you would have to simplify this before you could reduce it. And since we don't know what x minus 2 is, this cannot be reduced with that x. Okay, it goes back to this term right here where we kind of showed where we plugged in numbers. I can't just cancel out those 3's. It's the same idea here. I can't just cancel out those x's. Okay, that's my answer. All right, moving on to the next example. I have 3 terms on the top. When I have 3 terms, I know that I need to use my trinomial factoring. Okay, and so again, we're going to multiply over by 1, and so my multiplication number is 12, and my adding number is negative 8. Which numbers work? So hopefully you said negative 6 and negative 2 because those add to make negative 8 and multiply to make a positive 12. So when I'm factoring there, we make our parentheses. I can use my shortcut because the coefficient is 1. And we split up x squared into x and x, and then I have a minus 6 and a minus 2. When I move to the denominator, it's 2 terms, so I'm going to check for a GCF first. There is a GCF of 3, and we're left with x squared minus 4. Anytime I have an x squared term, I'm going to check here to see if I can factor further. And this is a difference of squares because 4 is 2 squared. So we can factor that denominator further, and it becomes 3 and x minus 2, x plus 2, and on the top we have x minus 6 and x minus 2. So hopefully you notice that the x minus 2's are like terms, so we're going to go ahead and reduce those, and it doesn't look like anything else can reduce, and so my final answer is x minus 6 on the top, and then we have 3 and x plus 2 in the denominator. Okay, next example. Again, this is 2 terms, so I know I'm probably going to end up doing a GCF there. I'm going to go ahead and go to the bottom because I think this is going to take me a little bit more space because I have 3 terms, which means I have to use my trinomial factoring, and I start that by multiplying over by 2. So my multiplication number is 12 and my adding number is 7. What numbers end up working for that? Good, 3 and 4. So this one I have to use the long way because there is a number besides 1 up in front. That coefficient is 2, so we can't use our shortcut. So we're going to go ahead and break this down, and this is going to be a 3c and a 4c, and I still have my plus 6 and my 2c squared. Now that we have 4 terms, factor by grouping. So my first group, I can take out a c, and I'm left with 2c plus 3. In my second group, I can take out a 2, and I'm left with 2c plus 3. And so this one, when it factors, we get c plus 2 and 2c plus 3. So we'll go ahead and write that up here. C plus 2, 2c plus 3. All right, and on the top, 6c plus 12, the GCF is 6, good. And then we factor out a 6, and we have c plus 2 left over. So anything that are like terms that we can reduce, we do. We notice that hopefully there is a c plus 2 that can be reduced. And so on the top, I'm left with the 6, and on the bottom, we have 2c plus 3. Okay. This next one on here, I can see that this top one, first of all, there isn't a GCF to take out. So I can see here that this is a cube, and so I'm going to see if I can factor by cubes. So 27 is 3 to the third, and we have y to the third plus 8 is 2 to the third. Once we have them all written as cubes, we cancel those cubes out, and we get 3y plus 2. The next step, hopefully you remember, is that we write this out with our 6 terms. So we have 3y times 3y times 3y, so 3 3y's, and then 3 2's. 1, 2, 3 2's. So 3y, so when we circle these now in pairs, and so my second parenthesis, 3y times 3y is 9y squared. In terms of signs, we know the next sign is going to be the opposite because the first one was the same. 3y times 2 is 6y, and then 2 times 2 is 4. Okay, and so now the top is factored, and I'm going to go ahead and draw my line here. The bottom, there's 4 terms, so we're going to go ahead and try factoring by grouping to see if this works. So if we group these in 2's, the first group I can take out a y, and I'm left with 3y plus 2. The second group I can take out a -4. So anytime there's a negative in front of that number, you want to take out that negative. And I'm left with 3y plus 2. And so that finally ends up being factored to be 3y plus 2 and y minus 4. Always check if you can factor further, but the fact that there's no squared terms here, you're not able to factor further. 3y plus 2 and y minus 4. We know that, this one over here, it's a y squared, but we know because we did cube factoring that the only way to factor that piece would be to use the quadratic formula. And right now when we're simplifying, we're not actually solving for a value. We don't need to do that further. So here the 3y's plus 2's cancel out, and my final answer just ends up being 9y squared minus 6y plus 4 over y minus 4. Okay, so we're going to go ahead and move on now to the next page. And we've actually talked about this a little bit already, but I just want to visually kind of show you what's happening. But sometimes the relationship between the numerator and the denominator looks really similar. Okay, and so what do you notice about the relationship? Okay, hopefully you see that this one, see up on top, the x is positive, and down here the x is a negative. On the top, the 4 is a negative, and on the bottom, the 4 is a positive. And so sometimes to see actually what's going on is you could substitute any number in for x. So I'm going to choose 2 just because that's an easy number to deal with. So if I were to put a 2 in each of those, 2 minus 4 is negative 2, and 4 minus 2 is a positive 2. And negative 2 divided by positive 2 equals negative 1. So basically right here, when you have these that are opposites of each other, they reduce to equal negative 1. And so when you're factoring to simplify the expression, and we did talk about this back in Unit 3, you can factor out a negative 1 out of either the numerator or the denominator to end up making them so that they are like terms and can reduce. Now, on this next one, we have x plus 4 and 4 plus x. What is their relationship? Hopefully, you notice that they're the same. Here, x is positive, here, x is positive. Here, 4 is positive, here, 4 is positive. And so, again, we can check this to see what's going on by plugging in a value for x. So, again, let's go ahead and choose 2. And 2 plus 4 is 6, and 4 plus 2 is 6. And 6 over 6 reduces to be 1. And so on this one, even though they're not written in the same order, they are the same. And you could flip this around if you wanted to write in the same order. But to simplify this expression, you can just reduce. Or you could think about it as you just leave them the same. They are the same, they're just written in different orders. So these reduce and can be 1. All right, so we're going to do some more examples. On the top one, again, right now I cannot reduce these. I want to see, can I factor something out so that I am able to reduce? Hopefully you notice we could factor out a 3 on the top, and I'm left with 2a minus 5b. And the denominator, if I look through here, I can factor out a 4, and I'm left with 5b minus 2a. So if you look at this one, hopefully you notice here the 2a's, this is positive, this one's negative. Here the 5b is negative, here the 5b is positive. So in order to make these reduce, all we have to do is factor out a -1 from either equation. And so to just kind of show you the long way, you could end up kind of doing the negative through the top or the bottom over here. But in this case, I'm going to take out a -1, and I still have that 3 that's in front. And then when I do that, I end up with a -2a and a positive 5b. And the bottom here is staying the same, 5b minus 2a. If you wanted to, and I'm just going to show you now that I've written it this way, if you wanted to just take out a negative here, change all the signs through just one of the parentheses, you could do that. So you end up with the same result, because -1 times 3 is -3. So if you want to, at this point, -3, you could rewrite this and write it as 5b minus 2a, and then we still have 4 over 5b minus 2a, so that they look the same. But this step right here that I just took is really unnecessary, because at this point we can see 5b is positive and 2a's are negative, and you could just reduce there if you want to. Either way though, your final answer you end up with is -3/4. Okay, next problem. One thing that I found that I like to do that you could do as well is I want these to be in descending order. It just makes more sense to me. And so if I rewrite this in descending order, I have a -y² plus 16. Well, we can't, when we're factoring, our squared term can't be negative. And so in order to make it so the squared term isn't negative, I'm going to factor out a -1. And I end up with y² minus 16 when I factor out a -1. Okay, at this point now, I notice that this is a difference of squares because 16 is 4 squared. So we have -1, and then differences of squares is going to be y minus 4 and y plus 4. Okay, the denominator is already factored in factored form, which is y minus 4 to the 7th power. And so here, I can reduce the y minus 4 with one of these, so I'm still left with 6. And so my answer is -1 y plus 4 over y minus 4 to the 6th power. So you'll notice here, if you would have done differences of squares here, that would have worked too. You could have gone 4 minus y, 4 plus y, but then you would have ended up taking out a negative in order to get the like terms to cancel out. So oftentimes I think it's easier just to write it in descending order. So again, if you look at this next problem, I might go ahead and write this in descending order. And so I would rewrite this as 8t plus 4, so it's in descending order. And then 6t squared plus t minus 1 is in descending order. So this is a 3-term and a 2-term. So the 2-term, GCF, we can factor out a 4, and we're left with 2t plus 1. Okay, in the denominator, we have to use our trinomial factoring, and we can't use a shortcut, so we multiply over, and I'm going to write it here to the left here. My multiplication number is -6, and my adding number is 1. So the numbers that work would be 3 and 2, and specifically -2. Those add to be 1 and multiply to be -6. And so when we break it down here, we get 6t squared plus 3t minus 2t minus 1. Then we factor by grouping, and we can take out a 3t, and we're left with t plus 1. Here I can take out a 2t plus 1, sorry, take out a 3t, and we're left with 2t plus 1. Here I'm just going to take out a -1, and we're left with 2t plus 1. So since these are like terms now, we factor them out, and we get 2t plus 1 and 3t minus 1. So we can reduce here because these now are like terms, and on the top now I'm left with 4, and the denominator I'm left with 3t minus 1. If you hadn't changed descending order, you just would end up with things in different spots. Like this would have ended up being 1 plus 2t, but you would have known that these could still reduce. But if you write in descending order, it's usually helpful to not have to worry about those things. So again, on this next one, let's start by rewriting it in descending order. So that's going to be negative 12p to the third plus 21p over 4p to the second minus 49. I'm going to go ahead and take out, these aren't trinomials, so we're checking to see for a GCF first. The GCF at the top would be negative 3p. And again, we never want our first term to be negative, and so we factor out the negative. So negative 3p, and that ends up leaving me with 4p squared. Hold on just a second. 4p squared. Oh, I just noticed that I wrote this wrong. Thank you. Okay, so 4p, there we go, minus 7. Okay, so again, we took out the GCF of negative 3p. We're left with 4p minus 7, because when you're dividing by a negative 3p to each of these terms, a positive divided by a negative makes a negative. In the denominator here, hopefully you notice that this is a difference of squares. There was not a GCF here. And so since all of those are squares, this is not working, which is why, and I forgot to put it on here, we wanted this to be a 16. So if you can change that to be a 16, that's what it was supposed to be. So this is actually a 4 squared. So when we factor that there now, differences of squares, still differences of squares, we have a 4p minus 7 and a 4p plus 7. These end up reducing, and we end up with negative 3p over 4p plus 7, which is our final answer. Okay, so your homework tonight is worksheet 4, numbers 1 through 3. It looks deceiving because there's like a whole bunch of letters per number, but that is your homework, and that's it.